Hello folks, Professor Watts here, and it's time to work through the Chapter 5 assignment from Excelonomics Macro, which is the growth model, the solo growth model. So we're going to have an exercise on kind of advanced model building and a nice little function-based feature that'll help us solve the model. It's actually pretty simple. I've got the graph set up to graph automatically, so we're just going to focus on building the model part with the functions. So here's what we've got. We have the solo model equation. So remember, y is a function of technology, capital, and labor. And as in class, we're just going to hold the labor part constant by setting it equal to 1, essentially. So what we have is technology and capital. And remember what that looks like. Y is the square root of k. The square root of k gives us that diminishing marginal product effect where we get less and less extra output as we add capital. And then technology is just a parameter, just a number that we multiply times the square root of k. And then we can scale up the technology parameter to show that we shift the growth curve, or the output curve rather, up as we add technology to the economy. And then we can dial in specific parameters for each of these things. So technology right here in B3, that's going to be our technology factor. We'll start it at 1, and if we want to increase technology, we'll just type in a number larger than 1 there. Depreciation, we have to account for the fact that once capital is created, it wears out or becomes obsolete over time. So we'll track the wearing out or the loss of capital over time through depreciation. And then finally, the investment rate, which is telling us how much capital we add every period, taking that out of real output, not consuming it, saving it, channeling it through usually financial intermediaries, banks, or stock markets or bond markets or what have you, to allow businesses to obtain that to grow their businesses, add more capital. So those are all the components we need, and we'll set up numbers and or functions for all of those. And then basically what we're going to do is a list of possible values for capital, corresponding values for output, depreciation, and investment. And then the steady state is where basically depreciation and investment equalize and counteract each other. And that will say that's the point that the economy will reach if there's no further changes in any of these parameters. And as I mentioned, this is chapter 5 of Excelonomics, so you can be following along in the book. I have a kind of a nice preface in the book that's a basic overview of the solo model, which you might want to check out. It's also in the class lecture, but I just wanted to make sure I'm agreeing with what the book says in this video. So I have my values as 1, 2.5, and 15 for technology, depreciation, and investment. So I'm going to go ahead and dial those in. So this goes hand in hand with what's presented in chapter 5 of the book. Okay, so this is what you will be seeing in your Excel file as well and in the book. So step 1 to actually create the model. So you just want to plug in values for the capital stock. So I'm starting in A6 here. I'm going down 1, 2, 3, and we want to do through 1,000. Now you could keep typing 4, 5, 6. That's going to take you a while, right? Excel has a nice thing called autofill where it will recognize the pattern you plug in. So I just have to type in 1, 2, and 3, select that entire range, and then I'm going to the fill handle now. And as I fill down, remember the fill handle, the little green box in the lower right hand corner of the selected range. I select that, and notice it's just continuing the sequence that I established, which is +1. So now I can just go and fill this all the way down by just scrolling here all the way down. I want 1,000. I think I put some outlining around these cells. Oh, that's too far. That's okay, actually. It doesn't matter. You go past 1,000, that's fine. I really only need to go here, 1,000. I'll highlight that, 1,000. Row 1,005. Okay, so there are all my possible values for capital. Now let's go over here to the real output column, column B. I'm going to start in B6, and we're going to run the solo model equation. We're saying output is equals the technology level, that's in B3, times the square root of the capital amount. Now how do we do square root? There's a couple ways we could do that. We could use the caret and put in a fraction for the power, or a decimal for the power, or we could actually run a square root function, SQRT. It's a function, so it's the function name and then open parentheses, and then that's going to be the capital amount in question here. Now, am I ready to run this? Well, this will turn out correct for capital equals 1. But what happens when I start filling this down? What's going to happen to A6, the reference? It's going to slide down to A7, right? And then A8, A9, and so on to calculate it for every corresponding level of capital down our rows. What about the B3, the technology parameter, technology level equals 1? That needs to always stay at B3, doesn't it? So I don't know if we've talked about this before. I think we did in the previous assignment. The way to lock in the reference, I go over here and click. I technically only need to put a $ in front of the 3. That'll keep it in row 3. But you can also use a shortcut to just click in anywhere on this reference, beginning, middle, end, and press F4 if you have a PC. And that locks in both parts of it, and that's fine. So we want to lock that reference. So put a $ in front of the 3 or a $ in front of both components, and then that will always stay put at B3. That's a absolute reference. And then the A6 is just A6. That's a relative reference. I also refer to this as locking the reference. Locking the reference, very important Excel tool that you'll use a lot if you're using Excel. So I think this will be the second time we've done it now, so hopefully you're getting the hang of that. Enter, run it. Okay, so at capital equals 1, output equals 1. Does that make sense? Yeah, what's the square root of 1? 1 times our technology level, 1. Okay, easy. And now let's just fill that by selecting, go to the fill box, double click, bada boom, and then you'll notice I've got the graph preset to graph all the values there. Of course, nothing shows up until we populate values. And there is our nice little output function. It's got that power function result. It's showing the diminishing marginal product of capital. Okay, so far so good. Now, let's track depreciation. Depreciation is what's happening to capital. So it's going to be a function of the value in column A here, the capital amount. And what is that? Well, we take the depreciation amount, C3, and that's always going to be in C3, right? For us, that's 2.5% or another value we can type in there. So again, lock that reference times the amount of capital we're at. So we're at row 6 here, capital equals 1. So it's the depreciation rate times the amount of capital. Lock the reference for that. Let the reference for the capital stay relative. So that's the amount of depreciation we're going to have. Fill that down, and that's a linear function of capital. So there it is in orange on our graph. I'll do this so we can see it all. Okay, and then finally, investment. Investment is a function of output. It's 15% of whatever level of output we get. So notice now I'm taking the value in column B and multiplying that by the investment rate. So that equals B, the amount of capital or the amount of output we have right now, times the investment rate, and the investment rate is fixed. Fill that all the way down, and there is our investment function there in gray. Steady state's going to occur where investment and capital meet, so that's somewhere right around in here. Now I don't have my range small enough to really see that. It looks like somewhere like between 25 and 50. But it doesn't matter because we'll have Excel find the steady state for us. Now, you might remember in the classroom I kind of showed that we could do this with algebra. With Excel, because we've already set up multiple values so we can graph it, we'll just use this table to find an approximate solution for the steady state. So what I want to do next is in this column E, steady state, is basically just run an logic function, just a basic logic function, which is going to be to test if the value for depreciation is less than or equal to the value for investment. And just this kind of logic function, it's not an if function, so the result here is just going to be true or false. Okay, so if D is less than I or equal to, it's going to say true. And the moment that that's not true, D is greater than I, it's going to say false. Okay, so let's go ahead and fill that all the way down. Now, where is steady state going to rise? Well, let's scroll down here until we see that, okay, between K equals 36 and K equals 37, this goes from being true to false. That means at K equals 36, depreciation is less than or equal to investment. In fact, in here it's exactly equal. And then at K equals 37, depreciation is just a little bit larger than investment. Depreciation is 0.925 and investment's 0.912. So somewhere right here is where we pass the steady state, right? So the steady state's approximately 36 or 37. Now we could set this to look for equal, but it's not always going to be equal because the equality might hit at a smaller value between 36 and 37. We only have 1 unit increments here. So what we'll do is just look for the first false, and we'll know that that is going to be pretty close to the steady state, close enough for purposes that we care about. So how can we tell Excel to say, okay, look at all of these values here in column E, find the first one that says false, but then what do we want there? Well, we want the value of capital that occurs at the corresponding row where this first says false. So how do we do that? Well, this is a kind of complex set of functions, but it's very useful. So it's going to be what we call an index match. So first of all, equals index. And what does this do? Notice it says returns a value or reference of the cell at the intersection of a particular row and column in a given range. So the particular row and column is going to be the row in column E that where false first occurs, and then what we want is the value corresponding to that row back over here in column A. This will sound complicated, so if you don't get it, don't worry, just do what I do. Index. Okay, so for the index, the first argument here is the array. The array we are indexing, and that's going to be the capital stock values in column A. So that starts at A6, and it's a range, so it's going to be colon A, and up through the 1000th, which is 1006. Okay, so that's the array. Now, the row number and column number to line up the value we want to grab, that's going to be the first occurrence of false in the steady state column, column E. So to get that, we're going to nest inside here a match function. Match looks up a value in a particular array, and then it kicks out the answer for the function, or the result of the function is the row value. So what are we looking for? We're looking for false. That's the lookup value, comma. Now you might be saying, Watts, didn't you teach us that text entries in a function have to be in quotes? Yes, I did, or I will. But this is not text. You need to note that true and false are not treated as text in Excel. They're treated as logic operators. So whenever we see true or false within a function, they do not need to be in text. If you put it in text, it can be an output of a function, but if you have it by itself, it's just a operator. Okay, so we're looking for false. Where are we looking for that? We're looking at in the steady state values, E6 through E1006. Match type, less than, exact, or greater than. Well, we're looking for false, exactly. So that's going to be 0. That's just a parameter on that. Okay, so close the parentheses, and that's it for the match function. The match function, remember, is the row number argument of the index function. So now I want to put a comma here and say, what column number are we looking for the index function? Well, notice that the column number argument here is in brackets. That means it's optional. If we don't specify that, it's just going to take it from the first column in our array, which it is only one column, so column A. So we actually don't need that at all. So I'm not even going to put a comma there. And I'm just going to put a final parentheses to close out the index function. Okay, and notice what it gave us. It gave us k equals 37. First instance of false down here happened at k equals 37. Correct, it did exactly what we want it to do. And if we change any parameter, now don't do this, but let me just show you. Let's say we double our investment rate up to 30. Well, what's that going to do? It's going to shift the investment function down here up, and it's going to push the steady state out to a higher level of capital, and that's going to push us up on the output function, right? So if I change the investment rate to 30, yeah, capital steady state now occurs at k equals 145, right about here on the graph, right? So you can see that that's the beauty of a model. Once we set it up, we can run any parameters and Excel will instantly solve it for us. Okay, now all we have to do is find the corresponding level of output for this steady state level of capital. Now we could use an index match again to find the output, the Y value for the capital stock at 37, which, I mean, it would be fine, and I wouldn't mind you practicing the index match function again, but I usually like to use the easiest possible tool. And for us, I think that's just going to be running the Solo model equation on this level of capital. So what is that? That is our technology parameter. I don't need to put this in dollar signs here because I'm not going to be filling, times the square root of the identified steady state level of capital. So right there, B3 times square root of G8. So we're going to have a steady state output of 6.08. And you can see here, if you find capital equals 37 in the graph, it's somewhere about right here. And then go up to the output function. It's going to hit the output function. Yeah, right there. It's above 5, but not quite close to 10. Yeah, it's about 6. Yeah, that looks about right. So the graph looks right. Everything looks right. Okay, so there it is. That's the solo model. That's how we can set up a model, graph it, solve it in Excel. Not that hard, I don't think. So let's move over to scenarios. Now I'm going to let you do most of this on your own. Step 1 is going to be to just build the model again. So everything we just did in build the model. Okay. Oh, I got to do all that typing again. Well, you can do all that typing again. Or if you want to be smart, you can do this. Copy everything we just did and paste it over here. Now, what happened? Well, for some strange reason, these functions aren't right. Maybe I got sloppy in my setup of the spreadsheet table, or maybe I'm just being really mean and making you check your work. So we'll notice here that I added an extra row for some strange reason. So if I come into my output function, B3, the technology level, is not grabbing the value now, it's grabbing the category label. So I just need to change that to B4. And then the square root of A7. Okay, so that's fine. And then the same thing for depreciation. This should be C4. And then the same thing for investment. That should be D4. Notice I don't have these in the same order, do I? I have C4 first here, the parameter first, and then the capital amount. And over here, I have the capital amount first, or the output amount first, and then the parameter. That's just to show you that order doesn't matter in multiplication. That's the commutative property of multiplication, right? Hopefully you remember that from junior high algebra. And therefore, order doesn't matter in Excel formulas. Okay, let's populate our capital range. Jump back up to the top. Let's autofill all of our formulas. And there we go. There's the nice pretty graph. Oh, we have to set up the steady state solver again. So that's going to be an index of our capital values. This time they start at A7 through A1007. The row number is the match function of what? E7. Whoops, or sorry, we're looking for false within E7 to E1007. By the way, this is a nice point where you can pause the video and copy what you're doing, or if you have the ebook, you can have the ebook open, because I have screenshots of everything, so you might find the ebook handy as well here. Either or both. Try to make this as easy as possible for you in terms of getting these functions right when you do this. So E7 through 1007 and the exact match, right? And then close that, and then close the index. So, whoops, I did something wrong. Okay, array. Number is the match function. Oh, I know what problem is. I didn't fill this. I didn't fill my steady state result all the way down. There we go. Okay, so now I got 37 for my capital stock with my index match function. Make sure you fill everything over here. And then we'll just run the solo model equation. So it's technology level times square root of capital stock value. Okay, so my initial setup here gives me 6 for output and 37 for capital. Those I want to record as my baseline. And then when I follow through the scenarios, which we're going to do down here in these boxes, we're going to compare everything to the baseline. The reason why we need to write this down again is because when I change things over here, so for instance, I'm going to double the investment rate, let's say. I don't know, I'll let you do what the scenarios tell you to do, but I'm just going to give you an example. So what happened is that capital went to 145 and output went to 12. So I'll write that down. So if that's what scenario 1 is telling you, for example, we'll write these results down. So at this, so I'm just copying out of the solver now, 12 and 45. And then what's my percent change for the baseline for output for y? So that's going to be the percent change equation. The final value for y minus the initial value, which is up here in the baseline, divided by the baseline. X2 minus X1 in parentheses divided by X1. I've got that formatted as a percentage for you as well. So 100% growth. If we double investment, we double output, right? That makes sense. But that came at a painful increase in investment. So then we might start thinking about, and I'll just delete this one, we might start saying something like, well, what if we kept investment the same and doubled technology, for instance? Now what did we get? Well, now we have a technology output increase up to 24 capital is up to 145, and our increase in output is this. So now, oh look, I got a 300% increase in output if I doubled technology versus only a 100% increase in output if I doubled investment. Which one would we rather increase? Which one gives us more for our money, so to speak, more bang for our buck? Clearly it's technology. All right, so that's what we're going to observe by working through these scenarios. See what happens in the solver results, write those down here, calculate the percent difference, and then finally I'm going to ask you a very simple question. What has a greater impact on steady state output? Pick one. Wink, wink. Save your file, submit it, make sure you follow these instructions. Should be pretty straightforward. Look forward to collecting these and seeing how you did, and hopefully you're starting to get really comfortable with doing some higher level functions in Excel. That's the cool part, at least as far as I'm concerned. Alrighty folks, good luck. Contact me if you need help. Ciao.